Imagine waking up to the news that a black hole, one of the most terrifying objects in the universe, is growing closer to Earth. That's not science fiction. It's a real scientific mystery that has left astronomers puzzled. The idea alone sounds like the start of a cosmic horror story, but what's actually happening is far more fascinating than frightening. Somewhere in the depths of our galaxy, a hidden giant is slowly feeding, growing, and bending the fabric of space-time itself. When astronomers first detected the strange motion of a nearby star, they knew something invisible and incredibly massive was pulling on it. That invisible presence turned out to be a black hole, now known as Gaia BH1, located about 1,560 light-years from Earth. In cosmic terms, that's practically next door. It's the closest black hole ever found, and what's truly astonishing is that it's not alone. It's quietly orbiting with a star, like an invisible partner in the cosmic dance. The moment scientists confirmed its existence, headlines exploded with dramatic claims. A black hole is growing near Earth. But how true is that? Is this monstrous object really expanding, devouring everything around it? The answer, as always with space, is both yes and no. Black holes can indeed grow, but not in the way most people imagine. Their hunger has rules, and those rules are written in the language of physics, not fiction. In reality, black holes don't chase planets or pull in everything within sight. They only feed when matter drifts too close: dust, gas, or the remnants of dying stars. Once captured, this material spirals inward, heating up and releasing light before vanishing forever. That process, called accretion, is what makes black holes grow. It's not an explosion, but a slow, patient consumption that can last billions of years. Still, the phrase "growing near Earth" sparks curiosity and fear. Could something like Gaia BH1 ever affect our planet? Thankfully, the answer is no. At over 1,000 light-years away, it's far too distant to disturb even the faintest atom in our solar system. But that doesn't make it less interesting. On the contrary, it makes it even more mysterious. How did something so powerful form so close to us without being noticed for so long? That's the question scientists are still trying to answer. Gaia BH1 hides in plain sight, invisible to the eye but detectable through its gravitational influence. Its discovery didn't just reveal a nearby black hole, it reminded us how little we truly know about what's lurking in our galactic backyard. The Milky Way, after all, might be full of these silent giants. To understand why Gaia BH1 and others like it exist, we first have to go back, way back, to the moment when a black hole is born. Every monster has an origin story, and this one begins with the death of a star. Every black hole starts its life in chaos. It begins as a massive star, dozens of times larger than the sun, burning with unimaginable energy. But when that fuel runs out, gravity takes over, pulling everything inward until the star collapses under its own weight. The outer layers explode outward in a blinding supernova, while the core shrinks into something infinitely dense. In that instant, a black hole is born. To put it simply, a black hole is space gone wild. Imagine the mass of millions of Earths squeezed into a region smaller than a city. Its gravity is so intense that not even light can escape, hence the name. It doesn't shine, it doesn't reflect. It simply bends reality itself. Around it, space twists, and time slows down to a crawl. This process might sound destructive, but it's actually one of nature's most efficient ways to recycle the universe. The energy released in a supernova helps form new stars and planets, while the black hole that remains becomes a kind of cosmic anchor. Paradoxically, from death comes stability. Without black holes, galaxies might not even hold together. But not all black holes are the same. Some are small, the size of a few suns, while others, known as supermassive black holes, weigh billions of suns and sit at the centers of galaxies. Ours, called Sagittarius A, rests at the heart of the Milky Way, quietly influencing everything we see in the night sky. The fascinating thing is that even though black holes are invisible, we can trace their fingerprints everywhere. The light of nearby stars, the swirl of cosmic dust, and even faint ripples in space-time all reveal their hidden presence. These clues help scientists piece together how black holes evolve and in some cases, grow faster than anyone thought possible. When we talk about a black hole growing, we're not talking about it physically swelling in size like a balloon. We're describing the way it gains mass by feeding on nearby material. The more it consumes, the stronger its gravity becomes, and the larger its event horizon, the point of no return, grows. In other words, black holes grow by devouring their surroundings, one atom at a time. This feeding process is key to understanding why some black holes like Gaia BH1 continue to expand even billions of years after their birth. It's not random, it's physics at its most extreme. But how do astronomers actually see something that doesn't emit light? That's where the real detective work begins. When we say a black hole is growing, we're not describing an explosion or a monster expanding in size. What's actually happening is an invisible process called accretion, the slow but relentless feeding on matter that drifts too close. Imagine a cosmic whirlpool pulling in dust, gas, and light until it vanishes into the unknown. Over millions of years, this feeding adds mass, making the black hole even more powerful. In essence, a black hole is a master of patience. It waits quietly in the darkness, tugging at anything that wanders into its gravitational web. Even a few stray molecules can make a difference over time. When enough material accumulates around it, friction and gravity create an inferno hotter than most stars. The result? A dazzling, glowing ring of light known as the accretion disk. This disk is the key to a black hole's growth. While the hole itself remains invisible, the disk shines like a cosmic beacon, revealing where the black hole feeds. The energy produced in this process can outshine entire galaxies. It's as if the black hole, despite being a symbol of darkness, wears a halo of light while it eats. But not every black hole is actively growing. Some, like Gaia BH1, are dormant, meaning they're currently not feeding. They might stay quiet for billions of years until something drifts too close. Others, like the titanic quasars in distant galaxies, are devouring matter at terrifying speeds, expanding faster than scientists ever thought possible. This growth isn't just about consuming mass. It reshapes the environment around it. As a black hole feeds, it releases radiation and jets of energy that can trigger or suppress star formation nearby. In other words, a black hole's appetite can influence the birth and death of entire solar systems. Understanding this process helps scientists see black holes not just as destroyers, but as architects of galaxies. Their gravitational pull organizes matter on a cosmic scale. Every time they grow, they help structure the very universe we live in. So when the media says a black hole is growing near Earth, it doesn't mean we're in danger. It means we're witnessing one of the most fundamental and mysterious processes in the cosmos. Growth in this context is creation as much as it is destruction. Black holes don't hunt, they wait. Their growth depends entirely on what the universe throws their way. But even waiting, they change everything around them. In the silence of space, these invisible giants continue their slow, unstoppable expansion. The idea that something can grow endlessly, yet never be seen, challenges everything we know about physics. It's a paradox that fuels both fear and fascination. And to uncover the truth about how we detect this hidden growth, we have to look deeper into the tools of modern astronomy. You can't see a black hole, but you can see what it does to its surroundings. That's the secret behind how scientists find them. Using powerful telescopes like Gaia, Chandra, and Hubble, astronomers look for the invisible fingerprints of a black hole, bending light, speeding stars, and radiation bursts. It's cosmic forensics at its finest. When a star orbits something invisible, its movement reveals a hidden mass. That's exactly how Gaia BH1 was discovered, not by direct observation, but by watching a nearby star wobble ever so slightly. That wobble meant something massive was tugging on it, and that something could only be a black hole. Another clue comes from the light around the black hole. Even though light can't escape from within, the material swirling outside emits intense X-rays as it's torn apart. Space telescopes pick up these X-rays, revealing where the invisible monsters lurk. The brighter and more chaotic the radiation, the faster the black hole is likely growing. Scientists also study gravitational waves, ripples in the fabric of space-time caused by massive collisions. When two black holes merge, They release a burst of these waves that can be detected on Earth by instruments like LIGO and Virgo. These signals not only confirm their existence, but help estimate their size and rate of growth. Detecting growth isn't just about finding black holes, it's about measuring their evolution over time. Astronomers compare old data with new, looking for subtle changes in the brightness or motion of nearby objects. Even the smallest difference can indicate that a black hole is feeding again. Sometimes galaxies millions of light years away flare up suddenly, a sign that their central black hole has awakened. These feeding frenzies are rare, unpredictable, and awe-inspiring. They remind us that the universe is alive in ways we're only beginning to grasp. Gaia BH1's detection was one of those rare scientific moments when theory met reality. For years, astronomers predicted that quiet, hidden black holes should exist nearby, and Gaia finally proved it. It's not just an isolated case, it's likely the first of many waiting to be found. By studying how black holes grow, scientists hope to answer one of astronomy's oldest questions. How did our universe evolve into the structure we see today? The answer may lie not in the light of stars, but in the darkness that surrounds them. Even though we can't see them directly, black holes are among the most powerful storytellers in the cosmos. They shape galaxies, guide the birth of stars, and remind us that sometimes the most important things are the ones we cannot see. And speaking of invisible forces, the next chapter brings us face to face with Gaia BH1 itself, the quiet giant that sparked this whole mystery. In 2022, astronomers made a discovery that would rewrite what we thought we knew about our cosmic neighborhood. Using data from the Gaia Space Observatory, they identified a massive, invisible object tugging on a star in an unusual way. The calculations revealed something astonishing. The object had the mass of nearly 10 suns, yet emitted no light. That invisible monster was named Gaia BH1. What makes Gaia BH1 so fascinating is not just its size, but its location. It sits in the constellation Ophiuchus, about 1,560 light-years away, the closest confirmed black hole to Earth. In cosmic terms, that's practically next door. But before you panic, that distance is still unimaginably vast. Light, traveling at 300,000 kilometers per second, would take over a millennium to reach it. Gaia BH1 is what scientists call a dormant black hole, meaning it's not actively feeding on surrounding material. It doesn't emit X-rays or energy bursts. It's silent, invisible, except for its gravitational pull on the star orbiting beside it. This silence is what makes it both eerie and exciting. It's there, quietly bending space, a reminder of how much we still don't see in the universe. Before Gaia BH1's discovery, astronomers believed that dormant black holes close to Earth were rare or even non-existent. But now, that belief has been shattered. The Milky Way could be home to millions of hidden black holes, each silently drifting, undetected, through the galactic void. Gaia BH1 is just the first clue. The discovery was made possible thanks to precision measurements. The Gaia satellite tracks the positions and movements of more than 1 billion stars with astonishing accuracy. By observing subtle wobbles in a star's orbit, scientists can infer the presence of unseen companions, like black holes. Gaia BH1's companion star, much like a candle flickering in the dark, betrayed the secret of the invisible giant beside it. This revelation is profound because it opens a new window into the dark side of our galaxy. For every star we see twinkling in the night sky, there could be unseen forces shaping its motion. The universe, it seems, is full of ghosts, black holes that live and move among the stars without ever revealing their faces. But Gaia BH1 isn't dangerous. Its gravitational pull is local, affecting only the star that orbits it. At over 1,000 light-years away, Earth is entirely safe. Still, the idea of something so massive, so close, yet completely invisible, captures the imagination. It's the kind of discovery that transforms curiosity into awe. Scientists are now searching for more of these quiet black holes. The hope is that by mapping their locations, we'll better understand how stars die, and how galaxies, including our own, are shaped over time. Each discovery brings us closer to decoding the invisible architecture of the cosmos. So, if Gaia BH1 is harmless, why do some call it a warning? because it shows how little we truly know about what's out there. If a 10 solar mass black hole can hide in plain sight, what else might be lurking in the shadows of space? To answer that, we need to explore what astronomers really mean when they say something in the universe is close. When we hear that a black hole is near Earth, our minds immediately jump to disaster movies, collapsing stars, shredded planets, the end of everything. But in cosmic terms, close doesn't mean dangerous. Space is vast beyond human comprehension, and even something 1,000 light years away is unimaginably far. To put it in perspective, 1 light year equals about 9.46 trillion kilometers. That means Gaia BH1 is roughly 15 quadrillion kilometers from Earth. If you drove there at highway speed, it would take you over 20 trillion years. So yes, it's close astronomically, but still impossibly distant physically. Astronomers use close to describe proximity on a galactic scale, not a human one. For them, 1,000 light years is practically within the neighborhood. Our galaxy, the Milky Way, spans over 100,000 light years, so something within a few thousand is indeed nearby. But that doesn't mean it poses any threat. Black holes only become dangerous when you get extremely close, within a few dozen kilometers of their event horizon, where gravity becomes irresistible. At Gaia BH1's distance, Earth isn't even a blip on its radar. Its gravitational influence is confined entirely to its local system. Still, it's understandable why the idea sparks fear. Humans naturally fear the unknown, and black holes are the ultimate mystery. Invisible, silent, and powerful. But in truth, they're not cosmic predators. They don't chase planets or hunt stars. They simply exist, obeying the laws of physics like everything else in the universe. In fact, black holes are far less dangerous than other cosmic events. A supernova explosion, for instance, could cause far more disruption if it happened within a few dozen light years of us. Gamma-ray bursts, solar flares, or rogue asteroids are far greater existential threats than any black hole in our cosmic vicinity. What makes black holes so captivating isn't their threat, but their mystery. They stretch the limits of our understanding, where gravity, space, and time merge into something almost spiritual. Their existence forces us to confront the infinite and the invisible. Gaia BH1 in this sense is not a danger but a reminder that we live in a universe far grander and stranger than we can imagine. A reminder that what we can't see can still shape everything around us. And while close doesn't mean dangerous, it does mean something important. We're learning to see the unseen. Gaia BH1 may be quiet now, but it's part of a vast network of black holes that silently govern the rhythm of galaxies. Next, we'll explore how these gravitational giants bend reality itself, and what happens to space and time when they come into play. The universe behaves differently near a black hole. Here, the rules of reality bend, literally. Space itself stretches, and time slows down to a crawl. What looks like empty darkness is actually a violent storm of physics at its most extreme. If you could hover near a black hole, you'd see the light of the stars behind it twist into beautiful, terrifying arcs, an optical illusion known as gravitational lensing. This effect happens because a black hole's mass is so concentrated that it warps the very fabric of space-time. Einstein predicted this over a century ago, and modern telescopes have confirmed it countless times. The more massive the black hole, the stronger the distortion. Near the edge, called the event horizon, the pull of gravity becomes so intense that not even light can escape. That's where space stops making sense. If you watched a spaceship fall toward a black hole, it would appear to slow down, frozen in time just before disappearing. From the outside, it would seem to fade, stretched and reddened by gravity until it vanished completely. But to the person inside, time would feel normal, until it wasn't. Inside the event horizon, all paths lead inward. There's no turning back. This time dilation is more than science fiction. It's been observed near supermassive black holes where time runs slower compared to regions farther away. In theory, if you spent a few hours near one, decades could pass for the rest of the universe. It's the closest thing we have to time travel, but with a fatal price. Movies like Interstellar got this surprisingly right. When the crew landed near the black hole Gargantua, time moved thousands of times slower for them than for those far away. The idea wasn't fantasy, it was based on real equations. The deeper you go into gravity's grip, the slower time flows. But these distortions aren't just cinematic, they're essential to how galaxies form and evolve. The gravitational influence of black holes shapes the orbits of stars and the flow of cosmic dust. Without that invisible pull, the elegant spirals of galaxies might not even exist. The warping of space is also why black holes act like cosmic magnifying glasses. Their immense gravity bends light from distant galaxies, allowing astronomers to see farther into the past. Through them, we glimpse the universe as it was billions of years ago. In many ways, black holes are the ultimate paradox, destroyers that also reveal. They consume matter, yet illuminate the universe by distorting its light. They trap time, yet show us the history of creation. Gaia BH1 may be quiet, but its gravity still sculpts the space around it. Even silent black holes leave ripples in the fabric of existence, invisible fingerprints on the map of the cosmos. And that raises a haunting question. What if one of these giants ever came close enough to touch us? Let's imagine the impossible. A black hole drifting into our solar system. It wouldn't sneak up quietly. Long before it arrived, its gravity would distort the orbits of planets, pulling them out of place. The first signs would appear in the outer solar system. Comets and asteroids shifting off their usual paths, chaos spreading like ripples on water. As the black hole approached, its influence would grow stronger. Jupiter, Saturn, and the other gas giants might be the first to feel it. Their orbits could become unstable, moons torn away, rings shattered. The gravitational pull would stretch and squeeze planets, creating tidal forces strong enough to crack worlds apart. By the time it reached the inner solar system, everything would be unrecognizable. The sun's delicate gravitational balance would be disturbed, possibly flinging planets, including Earth, out of orbit. Day and night, seasons, even the concept of time itself would lose meaning. If Earth somehow survived the initial chaos, the effects would be devastating. The planet would experience tidal heating, earthquakes, and radiation bursts. Oceans might boil or freeze depending on how close the black hole passed. The sky would twist into eerie shapes as starlight bent around the invisible intruder. Eventually, if we crossed the event horizon, everything, Earth, the moon, our memories, our history, would be stretched into a thin stream of particles. Scientists call this spaghettification, a poetic yet horrifying term for what happens when gravity tears matter apart atom by atom. But let's be clear, this is pure imagination. The nearest known black holes are so far away that none pose any danger to Earth. The chances of one drifting close enough to affect us are astronomically small, lower than winning the lottery every day for the rest of your life. Still, the scenario is valuable because it forces us to understand the laws of the universe. It reminds us how fragile and yet how resilient our planet is. The same gravity that could destroy us also keeps us alive, tethering us to the sun and giving shape to our days. Thinking about such cosmic what-ifs is part of human nature. We imagine destruction not out of fear, but out of curiosity, to understand our place in something so vast. Black holes may be terrifying, but they also humble us. They make us realize how tiny we are and how beautiful that smallness can be. In the end, even if a black hole never approaches, the mystery of what would happen continues to pull our minds inward, much like gravity itself. The closer we get to understanding them, the deeper the fascination grows. And speaking of fascination, in the next part, we'll uncover the hidden engines that power these cosmic giants, the glowing disks and energy jets that make them some of the brightest objects in the universe. It's one of the greatest paradoxes in the cosmos. How can something that allows no light to escape be among the brightest objects in the universe? The answer lies in what happens around the black hole, not within it. When a black hole is feeding, actively pulling in gas, dust, and even stars, it creates an incredible structure called an accretion disk. This disk glows with the energy of destruction. As matter spirals inward, friction and gravity heat it to unimaginable temperatures, millions of degrees. The gas begins to glow, emitting intense X-rays and gamma rays that can outshine entire galaxies. To an observer, millions of light years away, a single black hole can look like a cosmic lighthouse, blazing with energy that rivals creation itself. These active black holes are known as quasars, and they are some of the most powerful engines in existence. Each one sits at the heart of a galaxy, spinning rapidly, consuming matter, and firing out twin jets of plasma that stretch for thousands of light years. These jets move at nearly the speed of light, sculpting the galaxies around them like invisible hands shaping clay. The light from these disks and jets tells astronomers everything about what's happening inside. Different colors reveal temperatures, densities, and movement. By analyzing this radiation, scientists can measure how fast the black hole is spinning and how quickly it's feeding, information that was once thought impossible to know. The power generated by a feeding black hole is staggering. A single teaspoon of matter falling into the event horizon releases more energy than an entire city uses in a year. It's a reminder that destruction and creation are intertwined. The act of being consumed fuels the light that illuminates the universe. But not all black holes are so dramatic. Some, like Gaia BH1, are quiet for now, dormant, sleeping, waiting for their next meal. Others in distant galaxies are in full fury, devouring whatever crosses their path. In both cases, the mechanism is the same: gravity, heat, and time, working together in the most extreme form of balance imaginable. For scientists, studying these active black holes isn't just about spectacle. It's about understanding evolution on a cosmic scale. The energy they release influences how galaxies grow, how stars are born, and even how elements spread across the universe. Every flare of light, every jet of plasma helps shape the story of existence. What's most poetic is that black holes, symbols of ultimate darkness, are also beacons of discovery. Without them, much of what we know about the early universe would still be hidden in the dark. Their violent hunger gives us a window into creation itself. The paradox stands: from absolute silence comes the brightest sound in the cosmos, light born from darkness. And that light, in turn, gives order to the chaos around it. Which brings us to one of the most astonishing truths in modern astronomy. Without black holes, galaxies, and perhaps life might never have existed at all. Every galaxy has a heart, and at that heart lies a black hole. It might sound strange that something known for destruction can create stability, but it's true. Supermassive black holes, millions or billions of times the mass of our sun, act as gravitational anchors that hold galaxies together. Without them, the spiral arms of galaxies like the Milky Way might unravel into chaos. At the center of our own galaxy sits Sagittarius A, a black hole about 4 million times the mass of the sun. It doesn't dominate our skies or threaten our existence. It simply maintains order. Stars near it orbit at dizzying speeds, bound by its invisible pull. That gravitational stability allows the rest of the galaxy, including our solar system, to exist in balance. But black holes do more than anchor galaxies. They regulate them. When they feed, the energy they release through radiation and jets pushes away gas and dust. This feedback controls how many new stars can form, preventing galaxies from growing too fast or burning out too soon. In a strange way, black holes act like cosmic gardeners, pruning and shaping their galaxies over billions of years. Observations from telescopes like ALMA and James Webb have revealed just how intimate this relationship is. The size of a galaxy's central black hole often correlates with the size of the galaxy itself. It's as if the two evolved together, partners in a delicate gravitational dance that has lasted since the dawn of time. This balance extends even to the smallest scales. In galaxies where black holes go dormant, star formation often slows. Without that powerful flow of energy stirring the galactic gas, the system begins to fade. It's as though the galaxy's heartbeat weakens when its central black hole sleeps. In the grand design of the cosmos, black holes are both destroyers and protectors. Their gravity holds galaxies together, while their energy regulates the birth of stars. Too little, and the galaxy stagnates. Too much, and it burns itself out. Somewhere in between lies the perfect equilibrium, the rhythm of the universe. Understanding this relationship isn't just a matter of science, it's a matter of perspective. It reminds us that even the darkest forces in nature have purpose. What we call destruction is often the foundation of something new. If black holes vanished tomorrow, galaxies would unravel, stars would scatter, and the cosmic order would collapse. The darkness we fear is, in truth, the structure that holds everything we love in place. It's an irony as vast as the universe itself. The thing that consumes everything may be the very reason we exist. And if black holes are the architects of galaxies, what other secrets might they hold? In the next section, we'll explore the strangest facts about them. Black holes that spin, that sing, and that may one day simply evaporate. If you thought black holes were just silent voids, think again. Many of them spin, and not just a little. Some rotate at nearly the speed of light, dragging space and time around with them like a cosmic whirlpool. These are called Kerr black holes, and their spin is so intense it twists everything nearby, even light itself. In their grip, the universe behaves like a liquid, swirling endlessly toward oblivion. But there's another surprise. Black holes can sing. When two of them collide, they send ripples through space-time called gravitational waves. Detectors on Earth, like LIGO and Virgo, pick up these waves as faint vibrations, translating them into sound. The result? A low, eerie chirp, the universe's deepest note. We are, quite literally, listening to the music of gravity. These cosmic songs are more than beautiful. They're clues. Each wave carries information about the black holes that created it, their size, spin, and even how fast they merged. In 2015, the first detection of gravitational waves confirmed Einstein's prediction from a century earlier. The universe had spoken, and we finally heard it. Then comes perhaps the most astonishing idea of all. Black holes can evaporate. In 1974, physicist Stephen Hawking proposed that black holes slowly lose energy over time through a process now called Hawking radiation. Tiny quantum particles escape their grasp, causing them to shrink and eventually to disappear. This means black holes aren't eternal. Given enough time, far longer than the age of the universe, they'll fade away, leaving nothing but a whisper of radiation behind. Even the largest cosmic giants are temporary. Everything, it seems, has an end. Hawking's discovery changed our understanding of black holes forever. It connected the physics of the massive and the microscopic, hinting that the laws of the universe are more unified than we realize. Somewhere between gravity and quantum mechanics lies the truth, a truth we're still chasing. Some scientists even speculate that when a black hole evaporates, it might leave behind a remnant, a tiny fragment of pure energy, a kind of cosmic seed. Could these remnants be the building blocks of new universes? No one knows. The deeper we study black holes, the stranger they become. Each answer opens a dozen new questions. They are the ultimate teachers, not by what they show us, but by what they hide. And maybe that's their greatest mystery, not that they consume light, but that they illuminate the unknown. From distant galaxies to the quiet shadow of Gaia BH1, black holes remind us that the universe is both terrifying and beautiful. They are proof that the cosmos is not static, but alive, constantly evolving, consuming, and creating. Every black hole, whether silent or raging, is a chapter in the universe's ongoing story of transformation. They challenge everything we think we know. Inside them, the laws of physics as we understand them break down. Time stops, space folds, and causality, the very link between cause and effect, dissolves. To study black holes is to stare into the limits of human understanding, and to realize those limits can still expand. There's something profoundly human about our fascination with them. We fear the darkness, yet we're drawn to it. We search for meaning in the unknown, even when it threatens to swallow us whole. In that sense, black holes aren't just cosmic phenomena. They're mirrors, reflecting our deepest curiosity. Every time scientists point a telescope at the sky, they're not just looking for black holes. They're looking for perspective, for proof that our existence, though small, is part of something unimaginably vast, for a reason to keep asking questions. And maybe that's the real gift of the universe. It doesn't give us answers easily. It makes us earn them. It makes us wonder, doubt, and dream. The darkness isn't there to frighten us. It's there to inspire discovery. One day, long after the last star fades and the universe grows cold, the final black holes will evaporate, releasing their last breath of light. That faint radiation will be the last echo of existence, a cosmic sigh marking the end of everything, and perhaps the beginning of something new. In that silence, the story will continue. Because even if the universe ends, curiosity won't. It's the one force powerful enough to defy time itself. So the next time you look up at the night sky, remember, somewhere out there, in the vast ocean of stars, a black hole is quietly shaping the future. Not through destruction, but through balance, creation, and the eternal rhythm of the cosmos. The universe hides its greatest truths in the darkest places. And maybe, just maybe, that's where the most beautiful answers are waiting to be found.